Hey guys, welcome to Objective 1.4, Create and Implement Events and Callbacks. Today's objectives cover how to understand delegates, how to use lambda expressions, and how to create and raise events. Alright, so this objective really deals with just explaining and showing how to use events. But in order to use events, there are other things that we must know before we can use them. And that's why it goes over explaining things like delegates and lambda expressions, because it's good to know these things before you actually start working with events, because events can or actually do apply these technologies. Alright, so the first thing that before we start talking about events and what events actually are, let's go ahead and start with understanding delegates. And to understand a delegate, you obviously have to know, what do delegates do? Why do we use delegates? And things like that. So the easiest definition, or the most straightforward definition that I'm going to say right now, is that a delegate is something, or a variable, or some kind of object that holds a reference to a function. Now, this, if you never heard of a delegate before, this may be brand new to you, and it may be very weird how you're thinking, okay, how can a variable hold a reference to a function? Yes, I am saying that correctly, to a function or method. Normally, we're used to variables holding, when we're talking about reference types, we're talking about variables that hold references to other, to a class or an object. But when we're talking about delegates, a delegate is some kind of variable that can hold or point to a function or multiple functions. And when you do set up a delegate and you point to a function, you can use that delegate as if it is the function. So we'll see examples of like why we use this and how we use this, but pretty much how a delegate works is you define the delegate, and the delegate has a signature that's attached to it, and any function that you create that contains the same signature as the delegate, you'll be able to point the delegate to those functions, and it could be multiple. So if I have a delegate and I create a variable of that delegate, and I point to two different functions at the same time, I could use a delegate to call the two functions at the same time. Another use of delegates are if I say, okay, I create a function, and I say that this function and its parameters, it requires a delegate, right? I can say that this function requires a delegate. What that does is I can make a function that requires another function to be passed into it. So I can have a function like, I don't know, display, and the parameter of display could be a delegate x. That delegate x could have depending on its signature and things like that, it could require a function to be passed in. Now, once when you pass in a function to when you pass in a function to another function like that, there's a couple ways we can do it. We can actually pass in the function name. We could use lambda expressions, anonymous methods. Or a delegate. I mean, there's lots of different things that we could use to pass it in, and I'll hopefully show you some of these in this objective, depending on what the book goes through. But the first thing we're going to do is we're going to go over a basic form of a delegate. This is going to be using a single delegate, meaning we're only going to passing one function at a time. We'll do a multicast delegate in the next listing. So let's go ahead and do this. Alright, so for this example, I don't want you to get people confused with static stuff and things like that. I'm going to go ahead and create a class that is going to implement the delegate actually, and then we'll use that class in the constructor. We'll do things for that. So the class I'm going to create is going to be called use delegate. So let's go ahead and add class, and the class, like I said, we're going to call it use delegate. So this is our class. It's designed to use a delegate. So the first thing that I want to do is I'm going to create the delegate. So to create a delegate, it's going to be public, in our case, delegate, we're going to say, public delegate, then the return type of the function, or the return type of, what's the best way to explain this? Since a delegate can take in functions, we need to specify what functions it can take in. So we're specifying a return type of the functions that we can take in. So I'm going to say int. So I'm going to say public delegate int, then the name of the delegate, which is going to be calculate, and the parameters of the delegate have to be an integer, and another integer. So 2 integers. Now that I have that, I want to create 2 functions that have the same signature. So in order for the functions to be plugged into this delegate, they have to have a return type of int and take in 2 ints. So the first one I'm going to do is going to be an add. So it's going to be public int, because I need that int return type, add, and it has to be int x, int y. It has to have 2 ints in its parameters. So that's my first function. Inside of the body of the function, it's just going to be return x plus y. It's a simple function. And then the second function is going to be public int multiply int x, int y. And the body of this function is going to be return x times y. Oops. Oh. So now I have my delegate, and I have 2 functions with the same signature as that delegate. So that allows me to pass in the function to that delegate, or vice versa. So let's go ahead and create a constructor for my class now, saying use delegate. Not gonna have any parameters, and inside the body of this is where I want to create an instance or a variable of my delegate. So I'm gonna go calculate, because my delegate is called calculate. So I'm gonna create a new variable called calc. I'm gonna say it's equal to add. Add is the name of my function. Like I said, a delegate can hold a reference to a function. So you're not seeing this incorrectly. This is not wrong. I'm actually taking a delegate variable and I'm pointing it. I'm pointing it to a function. This add is a function. So this delegate is holding a function. So once I do that, I'm going to display it to the console. I'm going to say console.writeLine. I'm going to go calc 3, 4. So I'm calling the delegate. The delegate is holding a reference to this function. So if I can treat this delegate as the function now. This delegate is the function, so I can treat it as if it is the function. So I can go calc 3, 4, because calc is pointing to add, and that's what it set up. 3, 4, and it will return them adding each other together. Then I'm gonna go ahead. I'm gonna point the calc delegate to a different function. This time I'm gonna say calc equals multiply now. So now instead of pointing to add, I'm now pointing to the multiply function. So if I do the same statement here now, it's going to display a different value because we changed it from add to multiply. So now the calc is pointing to a multiply function, and when it calls this, it's going to do the multiply one instead because I'm pointing it at a different direction. So to test this, we just have to create an instance of it and instantiate it. So I'm going to go use delegate z equals new delegate, and that's it. This will do everything because this is inside the constructor. So let's go ahead and run this. And as you can see, when this loads, as you can see, we see 7 and 12, which is exactly what we're supposed to see. Inside the constructor, it does calc is first pointing to the add function, so it adds 3 and 4. Then calc is pointing to the multiply function, so then it times is 3 and 4. So that's what's going on. So the first thing that we need to note about a delegate is a type of object that can point. It points to functions, and it can point to multiple functions, which we'll see here in the next listing here in any second. So yeah, delegates hold references to other functions. Okay, so to do a multicast delegate, I'm going to create a new class. So the new class that I'm going to create is going to be called, Multicast. That's what the book uses. Yes. Okay, it's called Multicast. So let's go ahead and create a new class. Add class multicast. Okay. So this is my new class that I'm using. This is to demonstrate a multicast delegate. And a multicast delegate is simply a delegate that's holding multiple references to multiple functions. So the first thing I'm going to do is I'm going to create my delegate. My delegate in this time is going to be very basic. It's going to be public delegate void. My return type is going to be void this time, and it's not going to take in any parameters. And it's going to be called del. That's my delegate right there. My two functions I'm going to create are going to be called public void method1, and this just goes console.writeLine method1. And my second function is going to be method2. So I'm just going to copy and paste this. And it's going to say method2. So we can hook these functions up to this delegate because it has the void type, return type of void, which these do. And it takes in no parameters. However, I don't want to say that in order to use a delegate, the signature has to be the same, because that's not true. In the next listing, we'll talk about ways that we can still use delegates that are not, or that do not have the same signatures. But for the most part, they do have to have the same. You'll see the difference in the next listing. But anyway, let's continue on with this. So we have our delegate and our two functions. Now let's create our constructor. That's going to go public. Actually, no, they're not using a constructor. They're just using another function. So we're going to create another function called multicast. It's going to be public void multicast. And in multicast, all it's going to do is it's going to create a new delegate called D. It's going to start it off with method 1. So my delegate that I'm creating is pointing to method 1. Method 1 is just this one right here, and it works because the signatures are the same. However, I'm going to then also attach the other method to the same delegate. So to do this, I do D plus equal method 2. So I'm adding another function to the delegate. Now, there are other ways I could do that. I could say D equals D plus method 2. I could also do minus equal to remove delegate or remove functions off the invocation list. So there's all different syntax you can use with this, but it's pretty straightforward. So yeah, I have my two functions in my delegate now. Now all I gotta do is call them. I could just do this call I could treat D as it is a function because the signature of the delegate allows me to, I know for a fact that all the other functions that are inside this delegate have the same signature, so I know for a fact that this will work if I call it. So I'm just calling my delegate, which in turn is going to call method 2 and method 1 because I'm pointing at both of those functions. So inside of the main now, I'm just going to create a new class called multicast, m equals new multicast, and I'm going to go m dot multicast. And this will now it will go to the multicast. It will create a variable of my delegate, or an instance of my delegate. It will point to both functions, and then it does one call, and it will call both of them. So let's go ahead and run this. And there's an error. Hold on. Okay, sorry about that. Let's just call it multicast. I guess the book actually doesn't make a class called multicast, but whatever, it doesn't really matter. It really makes no difference. So I'm just gonna call it multcast like this, whatever. Let's go ahead and change it here. Sorry about that. Now let's run it now. Okay. So as you can see, the output, we're seeing exactly what we expected. Method 1, method 2. So what happens is when I call multicast, it comes into multicast and it creates a delegate, points to the first function, points to the second one also. Now it's pointing to both of them, and then I just call it, and then it calls both of them. Yeah, so this is an example of a multicast delegate. Now the reason why we're going over delegates is because the main point of this objective is talking about events. And events use delegates. To build an event, a delegate is used in the syntax. And the reason for that is because we need the power of the delegate for the event. Because I haven't really explained what an event is yet, but pretty much an event is a way that you can set up an event for a class, and they're called subscribing to an event. Other people that use that class can subscribe to an event, and depending on if some action happens inside the class, you can say, or you could do what is called fire the event, and the firing the event will notify all the subscribers that that action has happened. And I'll explain what I mean by that a little bit more, but in order to make events work, we need to know what delegates are. So that's why we're going over delegates first. Okay, so the next listing, which is listing 1-77 and 1-78. I'm not going to really show an example of this, but rather just explain it, because it's something really, even the examples in the books are really short. It's not that important. I mean, it is important, but it's very easy to understand. Pretty much what I said before was that the signatures of the delegate and the functions have to match in order to pass them in to the delegate. But that's not entirely true. Like I said before, there are two ways around that, and that's using covariance and contravariance. Pretty much, covariance makes it possible, I'm reading this from the book, makes it possible that a method has a return type that is more derived than it defined in the delegate. So if you have a function that with its return type that is more derived than the one in the delegate, then you can still pass it in. Then that will still work. And contravariance is just like that, but instead we're talking about parameters. So contravariance permits a method that has parameter types that are less derived than those in the delegate type. So if you just follow those two rules, those are other ways that you can use delegates. Now, the reason why these two different versions work is because of inheritance. You know, if you think about it, all of them logically, they all make sense logically because inheritance has an is-a relationship. And I don't know if you watched my video on inheritance in my C# fundamentals, but inheritance, like I said, builds an is-a relationship. So because of that is-a relationship, it allows you to treat something as if it's something else. So because of those rules, contravariance and covariance work. And if you want to look in the textbook or just Google it, covariance and contravariance for delegates, it's very basic. It's just a general rule of how you can pass things in. It's very similar to the thing where if you have an inheritance thing set up, and let's say I have an animal and then a cat is derived from an animal. If I have a function that says it requires an animal and a parameter, I could pass in a cat because a cat is an animal. So it's that kind of relationship. So okay, so yeah, that's covariance and contravariance. So the next lesson, we're gonna start talking about lambda expressions. Okay, so lambda expressions. This may be a confusing topic for some people, especially if you're just starting to learn programming and this is the first time you're seeing it. It can be kind of challenging. So before I explain lambda expressions, I think it's better to quickly talk about anonymous methods and what both of these are. So pretty much lambda expressions and anonymous methods are ways that we can create functions on the fly. So if we wanted to create a function that is going to be only used for a delegate, or a function that's body of the method is less than the actual signature of the method, then, or whenever we want to create a function on the fly without a name of it, or depending on whatever the different situations are, we'll use lambda expressions or anonymous methods to build those functions on the fly. And these functions don't have a name to the function because they're anonymous. Well, that's where the term anonymous methods came from, because they don't have a name. There's no name attached to the function. So anonymous methods work exactly what that is. It's a function with no name that's pretty much created on the fly. Lambda expressions were created, anonymous methods were made in C# 2.0, and lambda expressions came out in C# 3.0. Lambda expressions were made to cut back the time on anonymous methods, or to make anonymous methods but quicker. So pretty much lambda expressions are a quickhand for anonymous methods. So the reason why we're talking about lambda expressions in this right now is because delegates can use lambda expressions. Because you think about it, if you have a delegate which pretty much takes a delegate points to a function. Instead of pointing to the function with a function name and everything else, we could just point to a lambda expression, and that's a function that's created on the fly that's used maybe just for that delegate. Who knows? So I'm going to show you what that looks like now. Okay, so inside of useDelegate class, I'm going to create a delegate. The delegate is going to be the same one I think that we used before. It's going to be the calculate. So it's going to be public delegate, I think a return type of an int. Yeah, and then it was called calculate, and it took in an int x, int y. So this is my delegate. Now inside of, let's say the constructor again. So public useDelegate. This is where I'm going to use the delegate. However, last time we did this example, we had two other functions called add and multiply that had the same signature as this that we just attached using the delegate syntax. However, this time we're going to be creating functions on the fly using lambda expressions that we could hook into our delegates instead. So this may be a little confusing, this syntax that you're about to see, but I'm going to try to explain it the best I can. So the first step that we're going to do is we have to create a variable of our delegates. So we're going to say calculate calc. And then before last time we did calculate calc equals add, right? Because we had a function called add and this works. But now we don't have a function, so we need to make one on the fly. So the syntax for doing this is, the first thing is we need to define the parameters. Now there's a couple ways you can do this. You don't have to specify, like the book doesn't, you don't have to specify the data types of this because it can assume them from the delegate. But it's good programming practice to, I like to personally specify the types. So I normally go, these are my parameters, int. So I like to specify them. So I normally go int x, comma, int y. So I'm saying that these are my parameters. But like I said, you don't have to specify your parameters. You can, you don't have to, what am I saying? You have to specify them. But you don't have to put the name. You don't have to specify the data type. Like I said, the data type can be inferred. But I like to, because it's easier to read, I don't know. I like to just do it like this. You could say x, comma, y. But so these are my parameters to my anonymous method or my lambda expression. The next thing is the lambda operator, which is this arrow, equal, greater than. So this arrow is the lambda operator, or yeah, the lambda. This is for the lambda syntax. And then it's the body. So these are called statement lambdas. The book doesn't actually go into detail of what these are called, but yeah, these are called statement lambdas. There's also expression lambdas, which I think, let me see. Yeah, they go over that in the next listing. So these are statement lambdas, and with statement lambdas, they're only going to be one line long, so you don't have to use blocks. So I'm not gonna. And with statement lambdas, you don't have to say return. The return type is inferred because there's only one line of code in a statement lambda. So this part is going to be my body, so I'm going to go x plus y, and that's it. This is my function right here. This is my lambda expression function, right? So these are my parameters to my function. The lambda means that this is the body of my function, and I don't have to say return x plus y because this is a statement lambda. There's only one line of code, so it knows that after it does x plus y, just go ahead and return the value of it. So this is my entire function right here. So I created a function. This is a function with no name. This is an anonymous method. Although it's not using the anonymous method syntax, it's using lambda expression syntax. This is a function right here without the parentheses, without the curly braces, without the body. Without the name of the function. This is a function, and I'm saying pass this function into the calc. So if I went ahead and said calc 5, 5. Actually, let me do console.writeLine. So if I do calc 5 comma 5, it's going to use this function. So let's go ahead and do this. Now let's go ahead and run it. And as we can see, we see 10. Because what's happening is, inside of use delegate, it creates the delegate, and we're pointing the delegate to a function. This is a function. Now, I know if this is new to you, you must be confused right now. This is the same thing as going like this. This function right here and this is the same exact thing. If I went like this and to calc 1 equals add, these are equivalent right now. These are equivalent. This add is this function. This right here is a function. This has everything that this function has right here. The parameters, int x, int y. And then the body and return right here. It has everything in it. These are both functions, and this delegate is pointing to those functions. And I can use multicast with this if I want also. I can add another lambda expression into my delegate. And yeah, this is what it's used for. Now, anywhere you see a delegate, you can either pass in a function or a lambda expression, because a lambda expression is a function. So if I had a function that as a parameter says I need a delegate, I could pass in another function that matches the same signature as a delegate. I could pass in a delegate that it's pointing to a function, or I could just pass in a lambda expression, because a lambda expression is a function also. So this is you're probably confused right now, but these are really cool things. Lambda expressions are really cool. Now, I will say right now, because I'm just going over lambda expressions because it's required, or it's in this objective. But I started a new series. I don't know if you guys seen it yet. It's called Advanced C#. And I will be going over this probably in one of the lessons in that. The first one I did was operator overloading. The next one's probably going to be indexers. But lambda expressions are definitely on the list. So if you want to see a full video dedicated to just going over lambda expressions and seeing a bunch of examples with them, by all means, leave a comment. Tell me what you want to see, and I will make videos. Even if it's just one person who wants to see it, I will make a video explaining lambda expressions if it really wants. And even anonymous methods, even though they're outdated, who cares? You want to learn programming? Post. Say, I want to know how anonymous methods work. And I will make a video going over anonymous methods and things like that. Even though maybe eventually I will cover it, even if you don't say it. But if you do say it, maybe I'll cover it a lot faster than I would have normally. But anyway, so yeah, this is lambda expressions. This is my lambda expression right here, or more specifically, statement lambda. This is a statement lambda because there's only one statement and there's no return keyword. And we're going to go over expression lambda right now. Yeah, the next listing 1-80 is creating lambda expression with multiple statements, also known as expression lambda. Alright, so let's just go ahead and modify our lambda expression to now use multiple statements of code. And to do this, it's very simple. So let's just go ahead and delete this. So this time, I'm just going to go, I need my parameters, so I'm going to say int x, int y. So those are my parameters of my of my lambda expression. Then it's going to be my lambda expression, but here I'm going to now create some blocks. Oops, what am I missing? Oh, okay. So I create my blocks, or my block. Now inside my block, now I can go ahead and create multiple statements. So if I go console.writeLine, I'll say adding numbers. That's one line. And remember what I said, if you use multiple lines in a lambda expression, then you have to say return x plus y. It can't be inferred at this point. You have to say return now. So now this is my function right here. Right here is a function that is made on the fly right here, and it's only right here. This is identical to this function, pretty much without this. I mean, if I copy this, then they'll be identical. This function and this function are not identical, but this is a lambda expression function. It's built on the fly, and it's being assigned to a delegate. So this will obviously produce the same output, but it will just display adding numbers now. So let's go ahead and run it, and we see adding numbers 10. So the same function is being called. This is the function which is pointing to this function, but we added 2 lines of code, but this time now we have to specify return because we're not using statement lambdas anymore. We're using expression lambda, so we have to say return. Before it worked without return because there was only 1 line of code, and it knew what to return. So this is using single lined lambda expressions and multi-line lambda expressions. Okay, so now that we went over lambda expressions a little bit, we're almost to events. We're almost at events. So quickly, I mean, it only explains, there's only like really one example of events, event args, and then that's it. Yeah, this is a pretty small lesson. But still, okay, who cares about that? For now, the last thing we need to talk about is, even though the book only goes over one of them, I don't know why, whatever. So the last thing I want to talk about there are two popular predefined delegate types that can be used for us or used by us instead of making them. If our functions fall within this delegate, then we can just use the predefined ones instead of having to create our own ones. So the two of them, there's 2 different ones that are popular. The first one is an action, and that's what the book shows. The book shows you a quick example of an action delegate, which is simply just a predefined delegate that's made for us. But, however, there is also another one. The other one is a func, F-U-N-C. The func delegate. Well, the differences between them, I'll just explain really quickly. An action delegate allows you to create a function that has 0 to 16 parameters, but no return type. It's called an action because it does something, but it does not return anything. So the return type on an action is void. A func is almost identical to an action with its parameters, but it allows you to also have a return type. So you can use a return type with func, and with action you cannot. So the book only shows action, so that's what I'm going to do. So let me see what they did. Their example is really basic. I'm gonna show you something a little bit different, and I'll show you theirs also. So let's first do it their way, and then I'll maybe modify it a little bit. So inside of use delegate, I'm going to comment this out right now. Inside of use delegate, we're going to use the action. So in action, we say action, and then inside its parameters, or in these angle braces, we're going to specify what the delegate's parameters are. So we're going to say int, comma int. So our delegate is going to be int, comma int. So if we look at this as if we were creating a delegate, it would look like this. It'd be void. So this is what it would look like. But it does it for us. We're saying action, int, int. So it pretty much built this for us. That's all. We didn't have to type the rest. So action, int, int. Now that I have that, I can create a variable. So I'm going to say calc. And I can then do the same exact thing. I can do x or int x, int y. This is a lambda expression. Goes to I'll just do console.writeLine x plus y. So this is a perfectly fine statement. I created a delegate using a predefined delegate type. So action, which only takes in parameters. So this is the first parameter, second parameter. There's no return type. With func, you have a return type. But with action, an action has no return type, so it's int, int. So we need a function that takes in 2 ints and returns nothing. So we built a lambda expression that did that right here. and then I could just call calc 5, 5 like that, and everything is fine. If I run the program, we'll see that 10 again being displayed. So yeah, the action and func are just predefined delegates that we can use instead of having to create them on our own. They're just predefined types that we can, using I guess you would say generics. We can modify the parameters and things like that for however we want to use it. Okay, so now that we went over all delegates, lambda expressions, built-in delegate types, and things like that, we're finally ready to go over what an event is. So, an event, like I said before in the beginning of this objective, I went over what an event was a little bit. And an event is a way that people who use the class or other things that are using your class, they can subscribe to an event, and depending on what your event is used for, you can fire that event depending on if something happens, and it will notify all the users of the class that something happened. And depending on what happened, then they can take action in their function that they subscribe to the event with. So the reason why we had to go over delegates is because delegates and events or it's because delegates and events go hand in hand. When an event is fired, the subscriber or the person that wants to know that the event was fired, the subscriber subscribes to an event using a function. So they'll subscribe to it and they'll pretty much pass in a function saying, I'm subscribing with this function. Once the publisher wants to fire the event and say, okay, something happened, it fires the event, which in turn calls the delegate, which goes in and calls all the functions that were passed in by the subscribers. And that's what notifies the users. It will call the subscriber's function, and then it will do whatever code that the subscriber wanted to do. So, for example, let's say we had a class that measured, let's say we had a class that measured how fast our car was traveling. Okay, if we set up an event that fired if the car went over 60 miles per hour. So to do that, we would create the event, set it all up, and then we would have it. If the car went over 60 miles an hour, it would call the event or fire the event, and every user who wants to know if that car went over 60 miles an hour, they'll get notified because their function that they subscribed with would be called, and then you know that the car went over 60 miles an hour, and then whatever your function does to handle that problem, it would do it. So that's why we use events a little for the most part. We also use events for working with graphical user interface or graphical applications. Events are the major part of that, and if you looked at my how to build a GUI application, you will see that events are a huge portion of it, because depending on what happens, let's say if a user clicks something, I need to fire the event and notify all the people that are wanting to know if the button was clicked. So events are really big with graphical applications. Okay, anyway, so that is the basics. Yeah, the basic of events. Now, if you do have the tech or have the book, Enlisting 1-82, which shows you the first, it kind of starts explaining events, but it doesn't actually use the event keyword, and it's pretty much showing you why we have to use events rather than just using plain old delegates, because you may be wondering, oh, well, I can just use a delegate, and I can pretty much do everything with just a delegate. And it pretty much just goes over some of the, I forget the exact what they're saying, but it goes over some of the problems of just using that, and then it explains why we use the event keyword. And that's what I'm going to start with, listing 1-83, showing you how to actually use an event the proper way. However, the author, I do not like how the author does it, so I refuse to do it that way. The author assigns a delegate, an empty delegate, to the event to start off with. And the reason he does that is so that there's always someone subscribed to the event, so the event will always fire or the event will never be null. However, I do not like that approach whatsoever. I don't know why. And everything I've ever learned, read, or heard about events, I've never seen someone really do it this way. So I'm not I mean, I don't know. Correct me if I'm wrong and leave some comments. Do a lot of people do it this way? I don't know. I don't like doing it this way. The reason why I don't want to assign a value to my event to start off with is because I like checking for if the event is null. Because if the event is null, that means no one's subscribed to your event. And if no one's subscribed to your event, there's no reason to fire your event. It's a waste of CPU cycles. There's no reason to do it. So I don't know why the author does it this way. Maybe to help people understand programming, I don't know. But it's a waste of CPU cycles to go in and fire an event that no one's actually subscribed to. I don't know. That's just me. Leave a comment if you think otherwise. Anyway, so yeah, I'm not gonna do it that way. I'm gonna check for the event being null first before I fire it, and when I start typing the code, I'll explain this all again. But the reason, if you subscribe to an event, then the event is not null anymore. So if you check for the event being null, that means that no one, and it is null. I mean, that means that no one is subscribed to that event. Or that means no one cares about what happens. That no one's looking for the information from that event. No one's subscribed to it. So that's how I'm going to do it. Once again, I don't know. I got some beef. I got beef with the author doing this. I don't know. If you do have the book or you do have an opinion on this matter, by all means. I mean, ultimately, it doesn't really matter. Like I said, you are wasting some CPU cycles. But in this day and age, it doesn't really matter. But, whatever. Tell me what you think about this. If you are familiar with this topic, leave a comment. Let me know. It's kind of interesting. Because I don't know why the author did it this way, but whatever. Let's move on. I talked about that a lot. All right. So to actually demonstrate this, I'm gonna change this a little bit, just because the book. I don't know this. God, I don't like something about this book. The book is showing you an example of an event, but it's not practical whatsoever. If I was learning programming and I looked at this example in the book, I'd be like, what the heck is going on? Why would it be set up like this? And it just doesn't explain. It's not practical how they do it. So what I'm going to do is I'm going to just dive a little bit deeper into this and actually make a class that makes a little bit more sense. So what I'm going to do is I'm going to create a class called car, like I was saying before. My class is going to be called car. My class is going to have a property that has a speed of, it's going to be a type double. It's going to have the speed of the car. So I'm going to go private double, let's say speed, and public double speed. This is a property. If you don't know properties, look at my fundamental video. Get return speed and set speed equals value. Okay, so this is my property, and I'm gonna use this with my event here in a second. But let's go ahead and make my event. So the syntax for the event is gonna be public, then the event keyword. Sorry, it's event keyword. Then it's gonna be your delegate. Now, once again, the delegate is whatever. Well, we know what a delegate is now, and a delegate can either be one that we made, right? So we could have made the delegate by using the delegate keyword and creating a delegate, or we can use a predefined delegate. So in this case, if I want to use the predefined, actually, wait, am I going to? Yes, I'll use the predefined delegate for now. I can't think ahead too far to see if this won't work. I think it will. But I'm going to say public event action. If I don't specify any parameters, this means that it will have no parameters and a return type of void as any function that can be attached to this delegate. Or to this event. So, this is my public event action, and then the name of my event. So, I don't know, on change is what they call it, whatever. So that is my event. Now, inside of my speed, this is my speed property. All I'm going to do is, if my speed goes over 60, I'm going to fire my event and notify all the subscribers. So that's all I need to do in this class first. So I'm going to go should I go? Yeah, I'm going to go speed equals value, and then I'm going to say if speed is greater than or equal to 60, I'm going to fire my event. To fire my event, the first thing I'm going to do, which the book does not do, which was one reason I have beef with it, check if the event is null. If it's null, that means no one subscribed to your event, and there's no reason to fire it. So I'm going to say if if onChanged is not equal to null. So if onChanged is not equal to null, then I'm going to fire my event. I'm going to say onChanged fire. I have fired my event. Now, this is it. This is pretty much it for my car class. If my speed goes over 50, it fires the event and it notifies anyone who's subscribed to onChange. OnChange is going to be fired if the speed is greater than 60. So now I have this. Let's go ahead and go to my program class. Oh, sorry about this. I didn't update it. I'll just delete it for now. Inside of main, I'm going to create an instance of car. So car equals new car. I'm going to subscribe to my onChanged event. So I'm going to say c.onChanged, and I'm going to subscribe to it. So I use the plus equal because I'm adding a function to it. Now plus equal. Now there is, because this is Visual C# and Microsoft is awesome, I can hit tab twice, and it'll automatically build my function that matches the signature of the delegate of the event. So inside of car, the delegate of the event is an action, which means has to have return type of void and no parameters. So it automatically created that function, return type of void and no parameters, and I attached it to the event. So now I'm all subscribed. Now I'll just make a message in here. I'll say console.writeLine, event fired. Car is greater than or equal to 60 miles per hour. Okay, so if the car goes higher than, it's this one. If the car goes higher than 60 miles an hour, it will fire the onChange. Since I'm subscribed to onChange, it calls onChange. If you remember how delegates work, once you add a function to a delegate, so I'm right here, I'm adding a function to the delegate. Once you do that, I can call the delegate as if it was a function. So this is what I'm doing right here. I'm calling the delegate, and it will call all the functions that are hooked up to that delegate. And because I'm hooked up to it, it's going to call this, and it's going to notify me that the car is changed from another class. So that's what's going on here. I know, trust me, when I was learning this a long time ago, I was like, what the heck? I don't understand. And if you don't, it takes practice, but I'm trying to explain it the best I can. Really, I honestly am. Now that I have this, if I run the program right now, nothing's going to happen because the speed isn't going greater than 60. If I write some code that makes it go over 60, so if I go like c.speed equals 5, it wouldn't do anything. c.speed equals 55, it still wouldn't do anything, as you can see. But as soon as when the speed went to c.speed equals 65, watch what happens. Boom, my event got fired, event fired, car is greater than or equal to 60 miles per hour. Obviously, if this was a real-world scenario, you wouldn't be incrementing the speed like this. Maybe it would be with the function that you hit like accelerate, and it would gradually go up. Or if you're hitting the W key and you're moving a car, things like that, etc. But as you can see, once the speed went to past 65, my event got fired, and then it notified me. I'm the caller. I created this class, and I subscribed to the event, and it notified me that the car went higher, and it called a function inside of my class, not even inside the class that is inside the car. It notified me through a different class outside of the car. That's why it has the relationship of publish-subscriber relationship, because I subscribed to it, and the publisher notified me and fired the event, and then it made my function call from a different class. So this is the basics with events. It really is. I mean, like I said, if you guys want to see this in more detail, leave a comment, and I will make more specific videos on this. But I'm sure you're confused. But like I said, I'm trying my hardest. And if I had a video that was dedicated to just events and not all this stuff, I could go in with more examples and show you other things. But yeah, this is the basics of events, and events are very powerful. They're very, very, very cool. So yeah, this is an event. Okay, so although there's a few more things in this objective, It's getting pretty long, and this is where I'm going to stop because the other things I don't really. I'm trying to teach you the fundamentals. Not the fundamentals. I'm trying to teach you what I think is really important. And although the other things are still kind of important, I don't know. They don't make the cut for the video unless, I always say, unless you want to see them, leave feedback and I will do them. But if you have the book, I mean, you can just look, and I quickly go over them. So the next thing that one is explained is listing 1-84, and okay, and it's just talking about that instead of using predefined delegates of action or func, you should or you can use a predefined delegate called event handler. And an event handler is just a generic made delegate for you that has 2 parameters. The first parameter is an object called sender, and the second one is an event args. And all it is, it's very simple. Don't let it confuse you. The delegate requires you to pass in a reference to the object that called or fired the event, and some information about it. Why was it fired? So with those 2 information, they built a class or a delegate called event handler, and you can use that if you want to follow the general guidelines of firing and handling events. So all it does is send an object, which is holding a reference to the object that called or fired the event, and the event args are just some information about why it was fired. You can create a custom argument by just creating a class and implementing event args, or inheriting from event args and doing whatever it requires. A constructor and a value called int value. So that's that. It talks about custom event accessors, so you can treat an event like it's a property, and you can have 2 accessors, add and remove, kind of how like a property has get and set. And the add and remove is just when someone subscribes and unsubscribes, and you can use that. You can write out the code for that so that you can do something if someone subscribes or unsubscribes. So depending on what they do, you can make a message, record some logs, I don't know. But yeah, so you can just treat that as a property, sort of, and just handle if it's get or set or add and removed. Make sure that you have to make sure you use locking. You have to use locks with that to make sure that everything is thread safe. Alright, and the last thing that went over in this is just explaining how exceptions work with events. If we have multiple people that are subscribed to an event, and normally it reads from the top down. So if, let's say, like the second person threw an exception, the third person, their event would never be fired. It would stop there. So it just goes over a way, and it shows you a way that you can manually enumerate over the invocation list and execute each subscriber's function one at a time. So that if an exception is thrown, you can handle it properly and still make sure every other person's function that they subscribe with is still called. It's pretty basic. It just uses a for each loop that goes over the invocation list and dynamically invokes each of them individually. It just executes each handler, and then it just catches the exceptions. If it catches the exception, it adds it to a list of exceptions, and then it checks the list, and then it just throws the exceptions. And so you can catch them at a later point. But by doing it that way, it allows you to make sure that all the subscribers are still, or all the subscribers' functions are still called. Alright, so that's it with this lesson, or this objective. We went over delegates, lambda expressions, built-in predefined delegates, events. Yeah, that's pretty much it. So the things that I skipped over that I did say or did mention, if you want to see those in details, by all means, comment and tell me to, and I will. And whatever you want to see next, anything you want to say, just write a comment, and I look at them all one of them I get every month. But just whatever, let me know what you guys are thinking, and I'll make some more videos and whatever. But yeah, so this was the basics of events, delegates, lambda expressions. I mean, if you never saw any of this might be confusing to you. And in my advanced C# area, you keep a lookout because there will be videos on all these topics probably soon in more detail, obviously. But yeah, so that's that for objective 1.4. The next objective is objective 1.5. It covers implementing exception handling. So that will talk more about exception handling, what it is, how do we do it, etc., etc. How do we make custom exceptions, I think. Yeah, create custom exceptions. Alright, so all that. So, I guess that's it. I hope you all enjoyed the video, and let me know what you guys think. Give me some feedback. Thanks for watching.